Saxon Algebra 1, Lesson 4. Welcome students. I am experimenting with a nighttime studio. I borrowed a ring light from one of my daughters who teaches English online to Chinese kids through a program called VIP Kids, and she teaches at night because it's daytime for them. So I borrowed one of her lights to see how that works on my paper, and I'm looking for feedback from you on how effectively you can see it. So let me know. I'll be asking you later what you think of the nighttime studio, and you can tell me what you think. Lesson 4, oh my gosh, you guys, it's just crazy long. So I'm going to focus on what you need to know in order to complete the lessons, all right? But I have to give you a little bit of theoretical knowledge so that you're well educated. So let me tell you first, let's talk about the alphabet. You know this alphabet. I bet you learned to sing the ABC song back when you were, probably 3 years old. And you learned these letters, but the letters themselves are different than words, right? Like apple, boy, cat, right? Just to choose some favorites. These are letters. They're the tools we use to put them together, but the words are what have the real meaning, right? Okay, there's a parallel concept in mathematics. These are what we should call numerals. We often refer to these as numbers. But numbers are actually things like what? 5260 is how many feet are in a mile, or 10 is the number of fingers that we have. I'm just trying to think of meaningful numbers. 365 days in most years, right? These are what we technically should be calling numbers. Numerals are kind of the raw materials, and numbers are how we give meaning to numerals, just like words give meaning to letters. So we often skip over this word numeral because it's a cumbersome word. But remember that the digits in themselves do not have meaning. It's only when we put them in a context of a number that they actually take on value. Okay, when you first learned how to count, I bet you were sitting with your mom and counting either your fingers or your toes, and you learned to count 1, 2, 3, 4, and on, right? Bet you $5 that you did. Later, you learned about the concept of zero. And you added that to the string of numbers. And you might not have actually counted that, but you understood the concept of zero. And that group of numbers is called the whole numbers. Eventually, you learned about what we call integers. And that's when we think about the fact that there's such a thing as negative numbers. Okay? And you realize that 0 is kind of just the middle, and you can go as far to the negatives as you can to the positives. And then finally, you learned about what we call rational numbers. And that's the idea that there's little numbers in between the big numbers, right? We have fractions, and we have decimals, and we have percents too, but I don't want to throw them into the mix now because that's confusing. So you know there's negative numbers, positive numbers, and you learned that there's little bits in between. A number line, which I'm sure you've seen before, is a great way to summarize all that you know. Let's put 0 in the middle. 1, 2, 3. So this number line has the counting numbers. It has the natural or counting numbers. That's the technical name of that group. It's got 0. It clearly shows the integers, right? Positive and negative. And while we don't write them in, this space in between each integer gives us a place where we can imagine all of the fractions and decimals that live in between 1 and 2, right? Like 1.15 or 1 and 76/77, right? There's all kinds of crazy little numbers that live in there. So the number line is a super useful tool for organizing these, and all of these numbers together are what we call the real numbers. And the definition, in fact, of a real number is that it can be found on the number line. Okay, so the number line is the organizer we can use to kind of visually display all of the real numbers. And very often, right around this time, especially if I'm meeting in class with my students, somebody will say, real numbers, what are there? Imaginary numbers? And the answer to that is yes, there are. There are numbers outside of this group called imaginary numbers. And we are going to learn about them. I think it's next year before we start these. I think it's Algebra 2. But we are going to learn about imaginary numbers, and they're cool. So there you've got that to look forward to, right? All right, so let's go back and talk a little bit more about the fractions. You have studied fractions considerably. If you worked with me last year, I beat you over the head with them. But that is kind of the last step before starting algebra, is that students really need to understand how fractions, decimals, and percents work. So this is just a quickie review. When we multiply fractions, oops, let's do it like this. We multiply straight across the top, straight across the bottom. 4 times 7 is 28. 3 times 5 is 15, right? So it's easy. When we add and subtract fractions, we have to do that whole thing with making the denominators match. Not multiplying. It's a piece of cake. We just go straight across. This is called an improper fraction, right? Because, in layman's terms, the top is bigger than the bottom, right? So this fraction is greater than 1. It's called an improper fraction. I love improper fractions. Mathematicians are not bothered by improper fractions at all. Back in the day when you were doing pre-algebra, we often changed these into what we called mixed numbers, right? And you'd reduce, well, it's not really reducing it, it's just restating it. We call that a mixed number. Here's how I feel about mixed numbers. I'm gonna go full on death face mode. I don't like mixed numbers. They're cumbersome and they are, don't be insulted if you like them, childish. We are advanced mathematicians and we prefer an improper fraction every time. John still uses a lot of mixed numbers in the beginning of this book. I say, drop it, you guys. We're moving on to impropers. Don't be afraid of them. They're cute. Okay, let's try on a division problem. 4 over 3, my 3 looks like he's bearing the weight of that 4, divided by 15 over 8. How do you deal with a problem like this? Remember, the first number stays the same. The sign changes into multiplication, and the second fraction flips. What? It's true. It flips. So now we can multiply straight across. It's 32 over, what's that, 45, right? So there's our answer there. That's the right answer too. All right? So remember, division of fractions has this weird little business in it. Okay, the fun thing about multiplying fractions is when you can reduce. And let's do a fun one. I like when John gives us 3 fractions. In this case, we're multiplying all of them. Remember, we can express multiplication with a dot or a little x. In algebra, we tend to drop this x thing because it looks like the x that we use as a variable, right? So we tend to prefer this for multiplication, or a lot of times we'll use parentheses. We'll get to that. But we're multiplying all three of these fractions, and remember the cool thing is that we can reduce or cancel whenever we see the same factor in the top or the bottom. So like this, we can reduce this because 5 over 5 equals 1. So what we're doing is we're saying there's no need to multiply by the top by 5 because we're going to multiply the bottom by 5. So let's just skip it. We don't need to because they're just going to cancel each other out in the end and turn into a big fat 1. Then we can do cool things like this. 3 goes into 6. So we can divide the top by 3. That leaves us with 1. We divide this by 3. That leaves us with 2. All right. Then, do we see anything else on top that goes into the bottom? 23 is prime, so that's not going to reduce. And there are lots of little tricks that we'll talk about as we go for how to know if you're done. But trust me, we're done. And so we multiply. Let's see, all we've got left on top, these I can write 1 by, is 21. And on the bottom, we still have this 2, and then we have the 23, so that's 46. So this is our final answer. Yay! All right. If John does throw, here, let me just try this problem because it looks really scary and ugly, but it's not hard. Let me just show you. It's a division problem. He wrote it as a fraction. What the heck? That looks confusing. And he's got mixed numbers in here. Well, I've been clear, haven't I, how I feel about mixed numbers? No, we don't do that. So the first thing I'm going to do is get rid of these mixed numbers and write this problem again with improper fractions. Remember, the way we do this is we multiply the bottom times the big and add the top. So 3 times 3 is 9, plus 1 is 10 over 3. Denominator stays the same. 5 times 2 is 10, plus 1 is 11 over 5. Okay, so now I've gotten rid of the mixed numbers. I feel much better, but this format is still bothering me a little bit. So I'm going to remember that the line always says divided by with an exclamation point. So that reminds me that I can write this as 10 over 3 divided by 11 over 5. And I recently read something that pointed out that this little symbol here is really a simpler way to write this presentation where you have the line with one number above and one number below, right? One number above and one number below. So this is a little picture, if you will. It's a symbol that represents this style of presentation where we have one number above and one number below, and we use it in this other format, but it links these two ideas together, and I thought that was cool. Okay, so now we've written it from fraction form into this form that looks more familiar to us, but we don't divide by fractions like this. We leave the first one the same. We change this to a multiplication, a single dot, and then we flip the second one. Later in this book, either in this book or in the beginning of Algebra 2, we're going to learn why you do that. All right, there's a reason for it. It makes sense. But for now, just trust me. You want to flip that second fraction, and then we can multiply straight across. Can we reduce anything or cancel? I say reduce a lot. Usually reduce means at the end of the multiplication. If we cancel, that's before the multiplication. I mean them interchangeably, which probably isn't cool, but work with me. Okay, I don't see anything that will reduce, do you? We can't go top to top. It's got to be top to bottom. So I can't do like 1 and 2 there. It's got to be one number on the top and one number on the bottom. They can be in the same fraction or they can be in opposite fractions, but it's got to be top and bottom. Okay, 50 over 33 is my final answer, and I do not need you to put that back in mixed number format. If you were to check the answer to this and you saw that the answer was what, 1 over 17 33rds, but you had written this, leave it in this format. I like it better. Just check to make sure that you're right. But I want to train you now to stay focused on mixed numbers. I mean, did I say that out loud? Improper fractions. All right. Now John's going to remind us how to add, subtract, multiply, and divide. And then he's going to remind us how to do it with decimals. So here's what I'm going to do. Let me just show you. Here are the basic rules for adding, subtracting, multiplying, and dividing. It's okay if you don't have your book, just trust me. It's on page 18 and 19 in this lesson. I'm not gonna go over those. I'm gonna assume you know them. I will always kind of talk through my calculations. So if you need a little refresher, I'll probably do it in the context of another problem, but I'm not gonna waste any more time on that. These are reviewing those operations with decimals. I'm gonna burn through these now because I know how easy it is to forget. So here's the example for addition. He tells us to add two decimal numbers. I'm going to write down the first one, 4.0016. And now the second one, what we know is that we want to line up the decimals underneath, right? That's the trick for adding and subtracting. 02163, 02163. So notice how I was careful to keep my columns straight like this. And what I see is that I've got more digits down here than I do up here. That's okay. And what a lot of people like to do is add in a 0 just so that you have the same number and everything looks straight and even. It's okay if you don't, but it's okay to do it. I will probably do it for a while and then I'll stop doing it. Okay, 3, 2, carry the 1, 3, 2, 0, decimal place, 4. That's the correct answer, okay? So it's all about lining up these digits and your decimal places so they're nice and straight, and then making sure that you're okay down here at the end, that everything lined up right. Yay. Example 4.2. This works the same way. It's subtracting. Now this is tricky because he says subtract the first number from the second number. That means the second number is the one that goes on top, right? If he said subtract 2 from 7, that means 7 minus 2, right? Subtract 2 from 7. And that's a really good rule of thumb, you guys. If you're ever confused about what's going on in a problem, try doing it, restating it with really easy numbers so that you can kind of make sense of it before you get into the complexities. Okay, so subtract from this number another number. Ready? 0.02163. It's the same numbers as up here, but this time we're subtracting them. And we know this from before. This has 5 decimal places. This one has 4. So I'm going to put the 0 there. I'm going to brighten these up so you can see them. And again, the rule here is just keep everything straight and lined up. Make sure your decimals are lined up. And then just subtract happily away. Oh, goodness. John's going to make us borrow. Oh my gosh, so many times, right? 9. Now I'm going to have to go all the way here. 3, make it 10, borrow 1, make it 10, borrow 1, and then finally there's 1 there. 10 minus 1 is 9. 9 minus 2 is 7. 9 minus 0 is 0. 3 minus 0 is 3. And right there is where the decimal goes. So it's, oh, I'm sorry, I did this wrong. Did you freak out when I made a mistake? 3.97997 is the correct answer. Mine got a little sloppy, sorry. So, lining it up and just having fun with your subtraction. Because that's so fun, right? Multiplying. Multiply. These are the two numbers he wants us to multiply. 4.06 times 0.016. I like to write the number with more digits on top. It just looks better to me if I have the more digits on top. So I'm going to leave that there, and I'm going to write 4.06. There's no right or wrong here. So it's okay if you do it the other way. You won't mess up because in multiplication, order doesn't matter, but it just feels better on my eyes. So remember the rules for multiplying with decimals is number 1, ignore the decimals. Number 2, multiply. And then number 3, we put the decimals in at the end. So I love decimal multiplication because we can be so cavalier as to just ignore. All right, we've lined up our numbers here on the right. We're going to start with this one and we're going to multiply up and across. 6 times 6 is 36. 3, and then 6 plus 3 is 9. And then we have 0, so I don't need to write those down. All right, we're cool with that. Now, the next digit is 0. I put a digit here to show that that represents a 0 in the tens place, but then I can just put zeros across because everything's a 0. Now I'm ready to multiply by 4. It's actually 400, so now I put 2 zeros there. 4 times 6 is 24. 4 times 1 is 4, plus 2 is 6. All right, and we're done with that. So now I can add these. Still no decimal problem. 6, 9, 4, 6, and then it's just 0, so I don't have to deal with that. All right, here is what we do now at the end of the multiplication problem with decimals. We go back to our factors and we count how many digits were behind decimals in the first place. There's one decimal, there's the other decimal. 1, 2, 3, 4, 5. Now we have to put in our answer 5 digits behind the decimal place. 1, 2, 3, 4. What the heck? We can't put the decimal there because then only 4 would be behind. We add another 0. We put in the decimal. And if you're feeling fancy and you want to put a 0 out front, you can. But the important thing is that 5 places are behind the decimal in the answer. So that's correct. Ah, that was fun, wasn't it? I know, I was having fun. This is a long lesson, you guys. I'm sorry. We still have a lot to do. I know. That's why we're only doing 1 a week. Is because these are so, or I guess we're doing 2 a week, but instead of 4 because there's so much to cover in these lessons. All right. Now we're up to division. Example 4.4, and it says divide that number by, okay, so remember that's like saying, if you're not sure, let me just squeeze in the word here, this should say divide. Give yourself the same instruction, divide 8 by 2. I put in easier numbers to make it easy. Okay, well that would be like 8 divided by 2, right? So that tells me the first number is the one that goes inside the division box, which I think is called the dividend, and then 2 goes on the outside. I think that's the divisor. So this number goes inside 6.039, and then on the outside 0.03. All right, so now we have to review the rules for what do you do with the decimals when you're dividing. Shoot, it's different than multiplication. We can't ignore them. We have to deal with them. So first we look and see if we have any decimals on the outside. Yes, we do. So those we have to bump all the way through the number. So I had to move it twice, so I have to move this one twice. All right? Once we get this one situated in his new home, we take him straight up to the answer. Right there. All right? This one stays right there. We don't have to do anything more. That one goes into that place. Now, we don't have to do anything special with the decimals. They're all settled and they're in the answer correctly. We just happily divide away. So this number has now just become 3. 3 into 6, oh, that goes twice. 6 times 3, or 2 times 3 is 6. We subtract, and now we bring down. We go all the way down there. 3 into 3 goes once. That goes up here. So we see right away, oh, let's go ahead and fill a 0 into that middle place because we aren't going to be using it. 1 times 3 is 3. We subtract, we get 0. We bring down the 9. 3 into 9 goes 3 times. That lines up perfectly there. 3 times 3 is 9. We're done. So our final answer is 201.3. It's absolutely fine with me to just box your answer in the middle like that. Like you don't have to rewrite it down here. Honestly, I kind of caution against it because the more you rewrite things, the more likely you are to just make a copying mistake. So it's okay. Just leave it right there. It's fine. Okay. Are you ready? We have one more section to review, and it's kind of a biggie. We're going to talk about unit multipliers. Unit multipliers are useful when we are converting a number that's measured in units, like say inches, and we want to convert it to feet or yards or miles, right? So we want to change the unit that we're measuring in, and we use something called a unit multiplier to do that. If you have used the Saxon curriculum before, you know that John has a very specific way of doing this that I love. I can't speak to other curriculums, but I know that I never learned when I was coming up in high school. I didn't learn this technique in such a specific and exact way. And when I first saw John's way, I rolled my eyes and I thought, John, you're making too big of a deal of this. But that was 20 years ago. I'm now convinced that John's way is the best way, and that if you learn how to do the unit multipliers his way, your life will be better for it. So I'm going out there on a limb, all right? So I will show you how to do it. Let's start with example 4.5. In the beginning especially, you're gonna look at it and go, oh my gosh, you're making too much of this. You'll be like me, I bet you. But trust me, we'll be worth it. Use one unit multiplier to convert 32 feet to inches. Okay, so 32 feet is what we're starting with, and we want to end up with a certain number of inches. We don't know how many inches yet, except we can probably, you can probably do it in your head, but we're going to learn how to do it on paper. So this is what we're starting with, and we know we're going to multiply it by some conversion factor, some unit multiplier that's going to adjust from feet to inches. Now, we start by going, how many feet are in an inch? Oh yeah, there's 12 inches in 1 foot, or another way of saying the same thing is that there's 1 foot for every 12 inches. I know these are exactly the same. I just wrote them. I wrote the same thing in 2 different ways, but these are useful in different situations. How do we know which one of these belongs in our box? We look at the beginning unit. This is in feet. We want to use the conversion factor that has feet on the bottom. Okay? So we want starting unit on the bottom, the denominator, but it's easier to remember on the bottom. All right? Starting unit on the bottom. The reason why, now I'm going to copy this into my box. Later we're going to do this in our heads. We won't write this all out, but for now I'm writing it out so you can see. These are my 2 options. I choose the one that has the starting unit on the bottom. I put it in here, and now we're going to multiply. Here's where the magic happens. We can cancel units just like we can numbers, like we did back when we were multiplying the fractions. So if I've got feet on the top and feet on the bottom, they cancel, right? That's cool. Now we're left with inches, which is exactly what we want. And so now we see that 32 times 12 is the number of inches that we want to have in our problem. I don't even need to multiply this out. I'm just going to put a box around this. In John's solutions, you don't even have to multiply it out. You can do this with parentheses too. That's another way to show multiplication, and that's the way he often does it. You don't have to multiply it, you just show that's the final answer. Now, you may be thinking, I knew to do that. You just take 32 and it's feet to inches and that's 12. Your brain may understand that, but trust me, we're gonna get to the point where we're using 6, 9, even 12 unit multipliers to adjust a number. You're not gonna be able to do that in your head. So practice now learning how to write this out so that when it gets crazy, your brain will be like, I got this, it's not a big deal. Okay? Trust me that when you get to college level chemistry classes and you're doing these kinds of conversions as part of your chemistry work, you're gonna look at them and go, oh, I know how to do these. I learned how to do these in Algebra 1. And everyone else in your chemistry class is gonna come up to you after class and go, will you show me again how to do that calculation? Because you'll get it and they won't. And trust me, I've had so many of my former students come back to me and say, oh, you know that thing about the chemistry and the unit conversions? You were right. No one else knew how to do them but me. And I will say, thank you, John, for teaching us. 4.6, use 1 unit multiplier to convert 36 feet. Now you'll notice I'm giving myself a lot of space. That's because I know later we're gonna need it. Right now we don't so much. 36 feet to miles. So I'm gonna draw a blank there. Later I won't be so kind of fill in the blanky, but for now I am. Now you may not know how many feet are in a mile. I'm gonna tell you, write it down with all your other formulas on the cover of your book. So here, let's see, 1 mile equals 5,280 feet. Okay, that one you might not know. I bet you know there were 12 inches in a foot, but this one you might not know. Okay, so our two choices are for every 1 mile, it's 5,280 feet. Whoops, I wrote that wrong. 5,280 feet, or there's 5,280 feet for every 1 mile. Those are the 2 unit multipliers that connect. I know I'm using a different style here, but just play along with me. These are the 2 ways we can write the relationship between feet and miles. We want the one that has our starting unit on the bottom, so that's this one. Now remember, if we were trying to go from miles to feet, we'd want this one because that has miles on the bottom. We want to set them up so that they cancel. So that's why the rule is always starting unit on the bottom fraction. That's the one we use. So 1 mile, 5,280 feet. Again, later we'll be doing this in our heads, but I'm writing it out for now. Now the feet cancel, top and bottom. We're left with miles. Yay, that's what we want. And we go across, we're multiplying fractions, right? We're multiplying these. And sometimes some students like to put that over a 1 just to keep it perfectly clear. 36 times 1, let's just write 36 on the top and 5,280 on the bottom. And that is the way we can represent our answer. You do not have to do that calculation. John shows it, but you don't have to. Just show it as a fraction. All right, example 4.7. Are you tired yet? I bet you are. I bet you're tired of listening. I personally couldn't have more fun. Use 1 unit multiplier to convert 47.25 inches to centimeters. Oh, okay. This one's a little bit different because we're going from what we call English units, inches, feet, miles, yards, to centimeters, which are a metric system, right? Meters, centimeters, millimeters, kilometers. They're all units of length, but one is the English system, which nobody in the world uses but the US and I think Hong Kong, and centimeters, which is the metric system, which is what everybody else uses. Okay, so we can do this. The important unit multiplier when we're trying to go from the English system to the metric system is this. Every 1 inch equals 2.54 centimeters. This is one for whoops, that should be inches. This is one for the back of the book as well. So let's write that. 1 inch equals 2.54 centimeters. Yeah, that's a good one to know. Memorize it, but write it there too, so you've got it. All right, so these are our 2 options for our unit multiplier. We're going to use one or the other. We want our starting unit to be on the bottom. So that's this side, right? Last time it was this side. And it doesn't matter which order you write these in. All that matters is that you understand that, yeah, you are writing the same thing twice. When I first learned how to do these, I thought, it's the same thing. Why am I writing it twice? Well, it does make a difference because we want our starting unit on the bottom. So this one wouldn't work for us. But this is the same relationship, just written in the other format, but it's exactly what we want. 2.54 centimeters for every 1 inch. Now we can cancel the inches, top and bottom. I can put this over 1 if it makes me feel better. We're multiplying here. And so our answer is going to be here. I'm going to scoot it over a little bit. I didn't give myself enough room. It's going to be 47.25 times 2.54 centimeters. That's our final answer. Right? Don't have to multiply it through. Yay! As John says, a numerical answer is not necessary. So we will leave the answer as it is. I agree. Okay, we have 3 more to do. I know, you guys deserve a sandwich after you get through this lesson. It's so long. All right. And remember, I think it's totally cool that you guys are watching these lessons together. Some of you are. You're watching them together at your other school. That's absolutely fine with me, but I also know that it's hard to gather information, or let's put it this way. You gather information differently when you're in a group setting than you are when you're on your own. So if you get home and go, dang it, I don't remember what the heck she was talking about, just watch the video over again, or just watch part of it over again. That's one of the great advantages of having these videos, is that you can basically resurrect me to tell you about it again if you so desire. So use that to your advantage. All right, use 1 unit multiplier to convert 42 meters to centimeters. And John is helping us. And he tells us that there's only 1 unit multiplier, so I'm going to draw in my box. Okay, it's important to remember that this unit multiplier we're using is always equal to 1. And I'll explain that in a minute when we fill it in, but that's important. I'm going to put this over a 1. Now we have to figure out what's bigger, a meter or a centimeter? Well, anyone who's lived outside the US is probably comfortable with this, but a meter is about, you can't see because I'm putting my hands apart, but you can't see me. Most dads are about 2 meters tall. A meter is roughly like a yard. A centimeter is like this, right? Not even, it's like that. Okay, so a meter is bigger. How many centimeters are in a meter? Every 1 meter is 100 centimeters. Centimeter implies 100, like a century or a cent is 1/100th of a dollar. Okay, and then we can write it the other way, 100 centimeters for every 1 meter. Okay, which one do I use? I look at my starting unit. Meters I have up there, so I want meters on the bottom, so that's this one. So I copy it. Now, this is what I meant when I said this has to be equal to 1. 100 centimeters is the same as 1 meter. So this is a fraction that is equal to 1 because it's the same thing stated in 2 different units. So when we multiply this against it, we're not changing the value, we're simply changing the unit, if that makes sense. Don't let me confuse you. Okay, so now our answer, we cancel those. I always check to make sure that I end up, because like I said, there's going to be times when we have a big long string. 42 times 100. Okay, again, you could probably do that in your head, but a lot of you probably could, but we're not going to do that. We're going to practice. 2 more, and these are going to get a little bit trickier. Example 4.9. Use 2 unit multipliers to convert 42 feet to centimeters. Okay, wait a minute. Feet are an English measure, right? Only used in the US. Centimeters is metric system. That means we have to switch from English to metric. Whenever we want to go from English to metric, we always, or vice versa, if we want to go from metric to English, we always get the English unit into inches or the metric unit into centimeters. This is how I always think of it. I think of this as a portal, and the only way to get through the portal is to be in these 2 units, right? This is the portal that divides the 2. And we have to get in, depending on which side we are in and where we're going to call through. If we're on the English side and we want to get to the metric, we have to convert ourselves to inches and then crawl through and become centimeters. And then if we have other changes to make, then we do that from there. And this is an example of that. In order to get from feet to centimeters, I draw out a little map for myself. First, we're going to go from feet to inches, right? Because we're on the English side, so we have to get to inches. And then we'll go from inches to centimeters. And then we'll be exactly where we want to be. So what that tells me is that I'm going to need, and John told us this too, we're going to need 2 unit multipliers. The first one will get us from feet to inches, and then the second one will get us from inches to centimeters. All right? And we'll be multiplying, and these will be fractions, and this will be over 1. All right, so I'm going to practice doing this without writing out the 2 unit multipliers every time, because you don't need to do that. I'm going to help you learn how to do it in your head. So first we want to go from feet to inches. I know the feet are going to have to be on the bottom, and I know the inches are going to have to be on the top. How do I know feet have to be on the bottom? Because they need to cancel. That's what we're starting with. So I need them on the bottom. My map told me I want to go from feet to inches. All right, which is bigger, a foot or an inch? A foot. How many inches are in a foot? 12. That's how I go through this process in my head. Now I can cancel the feet, and now I'm ready to go from inches to centimeters. Okay, I've got inches on the top. That means I need inches on the bottom, and then I'll want centimeters here. That way these will cancel. All right, cool. Which is bigger, an inch or a centimeter? An inch is, and there are 2.54 centimeters in an inch. If this is too much, trying to carry this all in your head, go back to writing out your 2 choices and then choosing from there. But if you're feeling comfortable with this, go ahead and start carrying those in your head. That's fine with me. Now we ended up with centimeters. That's where we want to be. Now all we have to do is go through and simplify this multiplication. I can see I've got 3 numbers in the denominator and just 1s in the bottom. So I'm going to write my answer is 42 times 12 times 2.54, and that got a little messy. It's those 3 numbers multiplied together, centimeters. That's our final answer. All right? Yay, we did it, you guys. Here is, wait, I missed something. Oh, there's one more. Shoot. All right, we'll do one more. We're not done. I'm sorry. Example 4.10. In this one, we want to, it says use 2 unit multipliers to convert 4 miles to inches. Okay, and he tells us to use 2, so we can go ahead and draw them. It's nice when he gives us that big fat hint. Okay, we'll try doing this one without writing it all out. I put that over 1. This is all being multiplied. 4 miles to inches. Okay, so how are we going to do that? I don't know how many inches are a mile, but I know how many feet are in a mile. So I want to go from miles to feet, and then I want to go from feet to inches. Okay? So we're starting with miles. We're going to convert to feet. I want miles in the bottom, so it'll cancel. That means feet are up here. Which is bigger? That's the question I always ask myself next. Miles are bigger, so that gets the 1. How many feet are in a mile? Well, we wrote that down a few minutes ago, 5280. Did I write it correctly? Yes. Okay, miles cancel. We now have feet. All right, so this time I want to go from feet to inches. So my feet are up here. That's my starting unit now. So I want feet on the bottom, so they'll cancel. Inches on top. Which is bigger, a foot or an inch? A foot, that's a ruler, right? And there's 12 inches in a foot. All right, now the feet cancel. I'm in inches. That is where I want to be. And so for my final answer, let's see, all the numbers are in the numerator again. So it's going to be 4 times 5280 times 12 inches. And instead of rewriting it, I'm just going to put the box around it. It's neat enough. Yay. Okay, now we're really done. I just want to show you this. Right here, after example 410, before the practice, is a table of equivalent measures. It just shows you some of these relationships. We already wrote down how many inches, the relationship between centimeters and inches, and we wrote down miles and feet. You can copy any of these. I mean, you can Google them anytime you want, but here's the thing, you guys, the best way to memorize it is just to write it down and have it. So I encourage you to write down any of these that you don't already know. Like you probably know that there's 12 inches in a foot. But write down any that you don't know in your book, and then you'll always have them close by. Or this is the other thing. See these little Post-it tabby things? You can put those on a page that you want to reference, and that's another nice way to do it. All right, homework. This is the last lesson that we're going to do in this extended format. We're going to pick up the pace a little bit next week. That's why I did this. These lessons are so long, and I didn't want to overwhelm you guys at the very beginning. But now that we're 2 weeks in, I feel comfortable overwhelming you. Oops. Just kidding. Earlier this week, we did lesson 3. You did the practice, and you did the odds, and then you did the evens. And I want you to follow that same pattern. For lesson 4, I want you to do the practice and the odds, and then I want you to do the evens, okay? This Friday, we're gonna start our check-ins. So Friday, between noon and 3 p.m., I want you to FaceTime me. And I want you to plan on spending 15 minutes max. I'll chat with you, and then I'll give you a problem to work while you're online. You can just turn your volume down and sit there and work the problem, and then show me what you got for your answer. Like I said, 15 minutes max. If you happen to call me at a time when 4 other people are talking to me, that I wouldn't have that many on FaceTime. I think, how many can I have max? I don't know. But in any case, if there's a lot going on, if you happen to call when a lot of other people are, you can call me back if you don't want, if that's going to be crazy. So that's an option. That's why I want to get Zoom, is so that we could all do it together if we want to. But that's the check-in process. You call me sometime during this window. If you can't get to me during this window, call me and make another arrangement. Or message me. You don't have to call me to make another arrangement. But message me ahead of time and go, help. All right? That's all. I promise I'm done. Lesson 4 is history. Thank you for your patience. I know it was long. Good luck, and I will talk to you on Friday. Goodbye.